So that way we can get our speaker introduction up and out of the way. And I guess I'll go first on this one. My name is Bradley Ball. Thank you for joining us today. I'm kind of going to be the MC of this group. We've got a very talented crew to guide you through this presentation today. We have Kyle Todd with us, who's an HPE category sales leader for Mission Critical Solutions in the Americas region. Kyle is an expert in HP and the services and also the hardware that they provide. So it's wonderful that we have him on hand. So literally we have the source for you to be able to give you great information about this hardware. Prior to being with HPE, he had 23 years at Sun Microsystems. Kyle, please feel free to say hi to the folks at home and at work.
Greetings, everyone. Thanks for joining.
Excellent. Next up is Steve Hughes. Steve is our lead principal consultant, or the principal consultant lead for Pragmatic Works. He manages our group, which basically takes care of building out our offerings and scoping our different things, as well as being a technical expert. Steve likes to tell me that he's not that smart, that that's the other people, but he's actually quite brilliant, so don't let him fool you. He's done a lot of cool things. And his book, I was very surprised to learn when I looked on Amazon for that Q book, apparently going for $250 a pop. So he put a lot of great information in there. So Steve, if you wouldn't mind saying hi.
Hi, everyone, and please go out and buy that book. I'm sure I'll see commission at that point. So, no royalties, whatever that is. Anyways, thanks for joining us today. Thanks for joining us today. We look forward to talking with you about these, about the HP setups.
Yeah, the Kindle copy was only $20, so they should probably go for that. That's probably a little more economical. That they're not looking for the $250 pop. Well, you guys must have all signed those.
They're actually gold-plated. So
wonderful.
If I have a question, it's all good.
And then my name is Bradley Ball. I'm a Microsoft MVP. I'm the data platform practice manager for Pragmatic Works, and then you can read all about the stuff I've done over there. You guys are probably very familiar with me. So I'm going to go ahead and click Next, so we can wait about 5 seconds. And what we'll do is we will go ahead and kick this presentation off. And we're going to talk about why you're here, which is to be able to learn more about the Superdome X. So, Kyle, one of the things I want to do is I want to be able to look at this and go, okay, I'm looking at the balance for my can't-fail applications. I've got flexibility, analytics, cost on one side, performance, availability, and security on the other. Can you talk to me a little bit about the hardware and the solution that we've got and why we should be considering the Superdome X?
Yeah, there used to be a huge divide in the industry, and I certainly saw that in my time at Sun and in the first few years at Hewlett-Packard Enterprise, which was customers frequently had to make a choice between whether they wanted incredible performance, high availability, systems that you just periodically dust off because they just always run, and great security, or the trade-off was we're going to go for much lower cost, it's industry standard space, so we'll get a lot more flexibility, and we're going to be able to more quickly adapt to do analytics. But they frequently had to choose one or the other. They couldn't get everything. And that's the market condition that created what we've got now with Superdome X and SQL Server, which is instead of customers saying, I have to spend half of my IT budget with Oracle license and support costs, I have to buy enormous expensive hardware. Now you've got the economies of scale, that it's an Intel-based system, and you've got the cost advantage of SQL Server, plus, as you see from Gartner later on, you're not compromising anything when you deploy a mission-critical workload on SQL Server versus an Oracle or a DB2, and frequently you're actually getting more value. So it's a nice confluence of these two camps that used to be a decision, one or the other. Mutual exclusive, it's not anymore. You can get everything now.
Excellent. I'm going to go ahead and head to the next slide. Now, I'm not sure why, but I'm having an issue getting this magic quadrant to show up. It looks like it's going to appear, but for some reason it's not. So the one thing I wanted to say about this is that while you cannot see it in the slide deck, SQL Server actually for the first time is leading the magic quadrant for Gartner for ODBMSs. And this is fantastic for us because this latest release of SQL Server that we have, 2014, that we're working off of, has just grown by leaps and bounds, and 2016 is taking that to a whole nother level, and we'll talk about that in a moment. For those of you who might not be familiar with it, if you go out and Google or Bing TCP benchmarks and SQL Server for the latest batch in SQL Server 2014, it was the first time ever that we actually beat Oracle, and by a very, very wide margin. And the interesting thing is, the second that we beat them, there's a blog on MSDN that the SQL Cat team released about those results. Oracle actually sued the TCP benchmarks to try and get them not to release those findings. So SQL Server is just doing a fabulous job, really becoming the premier go-to market leader. The cost structure is much less, but at the same time, that it's such a feature-rich application. It has a fantastic user base. There's so many places that you can openly just go and find free training on it and the different technologies on it. It's fantastic, and it's actually getting to be the market leader. Kyle, Steve, anything you guys want to say on this?
Well, certainly on the performance level, what we see with the SAP's performance, and if you're not familiar with it, there's a standard benchmark for SAP environments, so this is ERP software, and SAP's is the one currency that everybody agrees is an accurate reflection of how SAP performs. We ran this benchmark, and we didn't run it with Oracle or DB2. We ran it with SQL Server on Windows on a Superdome X, and we set every kind of world record there is. So the highest performing 16-socket server for SAP workloads is actually SQL Server on Superdome X. So great real-world results versus theoretical benchmarks that are sometimes done in a lab and people can play around with them. That's not what this is. This is a real-world application, and it shows how well it performs.
Excellent. And I don't know why, but I have some graphics that are not showing it. There we go. There it is. And so one of the key things that we want to make sure people understand, and I probably should have asked for a poll question that asks how many people are using Oracle, but a lot of people who use Oracle as their mission critical applications are doing so because they've done so for generation after generation. We've got this wonderful motivational poster at the Pragmatic Works headquarters that shows someone in the running of the bulls over in Spain and says, just because it's a tradition doesn't mean that it's not completely stupid. So one of the things that we want to do is we want to take a look at the things that we traditionally do in business every now and then and go, is this really the best thing for our business? Is this the best use for our time, for our money, and for the investment that we make in our infrastructure? Kyle, do you want to add a little more to that?
Yeah, and what we encounter over and over again, since Oracle is now on the 5th generation of their Exadata server, is Oracle touts Exadata as the ultimate database appliance, designed specifically to run large mission-critical workloads, Oracle database. And the problem with it is it's now kind of getting long in the tooth. It's an old system, and it's based around an architecture that's not terribly efficient. It's a bunch of little teeny compute nodes separated by InfiniBand to a bunch of storage nodes. And InfiniBand is the culprit. The fact that you have to transfer everything back and forth across this InfiniBand wire creates incredible system latency. So Oracle realized a few years ago they weren't keeping up with just regular Intel processors. And so on a system like Superdome X or other servers. So to compensate for that, they went into overdrive to create very, very sophisticated software to try and address that performance latency issue from the network. And so the irony is they're not keeping pace with performance, but the price of Exadata keeps going up for software that's failing to keep pace with performance. So it's this weird vicious cycle. So you look at a graph and you look at what the cost of compute with x86 and SQL Server is, and it continually goes down year after year after year. You look at the cost to hit that same compute level with Oracle and Exadata, and it continually goes up significantly. So that's the message that we're bringing to customers is 10 years ago, if you decided to run mission-critical workloads on Oracle database, no one was going to say that was a bad decision. But it isn't a necessary thing to do today. You can get comparable or superior performance functionality for significantly less money deploying something on an open system like Superdome X with SQL Server versus a proprietary Oracle solution.
Excellent. So when we look at some of the places that we can use SQL Server specifically on a Superdome X, there were a couple key areas we wanted to hit. One of them is looking at near real-time operational analytics that won't allow for slow transactions. So when we discuss the hardware that's behind this, the Superdome X is really, the way I like to phrase this is, it is the Starship Enterprise. It is the flagship server that you're going to get that's out there for HP at this point in time. So if you're looking at utilizing something like in-memory OLTP, using the in-memory column store indexes that are shipping with SQL Server 2016, one of the things that you want to look at is actually having the physical memory that you need on hand. And Kyle, if I'm correct, the maximum physical memory you can have on an HP Superdome X is around 24 terabytes of memory, correct?
Yeah, that's absolutely right. It's huge.
And that's very important, because if you're using in-memory OLTP currently, the release that we got with 2014 was a really, really good release. It was a very solid V1 for us to be able to get. We're getting even further along with V2. The database size that you can have in-memory OLTP is actually increasing. I want to say to around 250 gigabytes. So that's 250 gigabytes that you're going to need to reserve in memory. If your in-memory OLTP database is that large, when you size that database, and the sizing techniques that you use it is, and not to get too technical here, but the in-memory OLTP system uses a multi-concurrent version store to make sure that we don't have to use locks or latches or any fancy stuff like that within SQL Server, which really lets us just operate within the nanosecond. And that's one of those key things is memory operates at the nanosecond level. Your physical disk operate at the millisecond level. That's 1,000 times slower. And whenever I like to show people how fast that is, here's a great example. By the time I complete this sentence, 1 billion nanoseconds have occurred. That's a lot of computation. And if we slow that down by 1,000, that's a lot that we actually lose when we're wanting our computers to just go really, really, really fast. So if you're looking at in-memory OLTP, or if you're even looking at SQL Server mission-critical applications for OLTP environments, this is a key area that you really want to look at. Another thing is, if you look at some of the marketing material, and Kyle and I had talked about this beforehand, it's kind of a misnomer. People say x86, x64, and what they're meaning is 32-bit software and 64-bit software support. The x86 chips, the Xeon processors, actually began supporting 64-bit software back in the early 2000s. So if you hear x86, one of the things I want to make sure people realize is this is a 64-bit machine. It has the 64-bit addressable window spaces, which means you get to look at all your memory in that particular way. Where that really starts to matter as well is when we get to our data warehousing. So in SQL Server 2016, and some of you are in the TAP program, and I saw a lot of people that were looking to go there, or you're in SQL Server 2014, so I'm going to talk to you for a moment. One of the key things you'll know is if you're in the data warehousing environment, column store indexes are a huge thing that you want to be utilizing. The writable column store index that was introduced in 2014 that we also have in 2016 allows you to be able to do batch loads to a column store. We super hyper compress that data in million row segments, and we can save a lot of space. I've gotten 8 to 10 gigs of data, and I've gotten it down to about 600 megabytes, and it was varying result data, not the same thing over and over again, so we got an artificial compression rate. This is what we typically see in the field. APS systems, which we work with our partner at HP quite a bit to be able to implement for customers, will use column store indexing by default, and we've seen hundreds of gigabyte sized tables be reduced and get about 30 to 40% compression savings off of those column stores. They're fantastic. But an APS is what we like to call an MPP solution. And if you look here, an MPP solution allows us to be able to scale out a data warehouse. If you can't scale out a data warehouse, your only choice is to scale up. Now, no matter what any person in sales may want to promise you, an APS is not right for every single workload. Steve can vouch for this, I can vouch for this. We've seen plenty of instances where people try and take a square peg and shove it in a round hole. There are specific areas that an APS excels in, but if you have a lot of dynamic shifting content, if you've got a lot of individual user databases for a SaaS application or something like that, if you need to let your end users have hundreds of different ad hoc queries running against a server, an APS is not right for that type of environment, in which case you're going to need data warehousing so that way you can actually scale up. The large memory accessibility that you have with this system, SQL Server 2016 will be able to use 12 terabytes of memory. 12 terabytes, that's huge. That really matters when your data warehouses start to get very, very big, because when things slow down, the number one performance hit that I see on data warehousing is they have issues where data is being read in and out of memory so often that we really can't buffer it. And so we're constantly reading off a disk, and that causes things to slow down, because remember, we go from that nanosecond range down to that millisecond range, and that's really where our performance starts to take a dive. So the ability for us to be able to address that is absolutely huge and absolutely critical. So when we look at systems like this, one of the things that we want and why we want to actually make sure that everyone has access to information a lot quicker is we want faster time to insights. If you're on 2016, then you know of the very exciting news that DataZen is being rolled into reporting services. Reporting services is also going to support HTML5. We're also going to have the capability to embed Power BI reports into reporting services. Reporting services is really getting a first-class upgrade, and via DataZen, it's going to be fantastic for mobile and industries like that. And in-memory OLTP is not just for for OLTP database workloads. It's something that I absolutely want on OLAP. That in-memory, one of the key places that I find businesses using this is they can load in-memory staging tables and then ETL that data out into wherever they're actually sitting it within their data warehouse. There are a lot of fantastic features to be able to use in-memory OLTP performance on. And it's not this that we're going to get some data compression as well in there. One of the things that we want to do as well is we want to make sure that we've got security. And Kyle, we were talking back and forth about this because there's some really amazing things that the Superdome X allows us to do. I don't want to steal your thunder on hard partitions, so I'm going to let you actually talk about this for a bit,
Okay,
and then
great.
I'm going to talk a little bit about how I could see this used in a SQL Server environment.
Okay, super. So one of the very unique features that Superdome X provides is hard partitions or electronically isolated partitions. And this comes from HPE's lineage with big Unix servers. So if you had servers from Sun or IBM or Hewlett Packard, you had electronically isolated partitions. And the benefits are a couple of things. One, if a server or partition fails, because these are electronically isolated, the other partitions continue to run. So it was great from a high availability standpoint, because if one failed, the rest of the system was still fine in production. But the second feature is that because they're electronically isolated, they are totally distinct. So if somebody is able to hack into a partition, the analogy I use is if a burglar breaks into a house and he's in the foyer of the house, he can go into any room he wants. That's what a soft partition world looks like. With hard partitions, burglar breaks into the foyer and there's a steel door in front of every room. So you don't have to worry about being the next Sony Pictures, because if somehow a system gets violated, or if one partition has less protection on it than the others, someone's only going to get into that partition, the warning bells go off, and the rest of the system is secure. So that's something that our customers have seen a lot of benefit from, is the fact that these things, even though they share a common backplane and they've got high availability because there's so much failover capability, the fact that they're truly isolated provides a level of security that doesn't exist in other x86 platforms running Windows.
Absolutely. And one of the key things I can see to be used for this, I mean, it is fantastic from the security point of view, but when you look at a large-scale type of build-up operation. Sometimes you need to have a dev test prod. Sometimes you're looking to be able to stand up your OLTP environment. You may need an R environment. You may want some areas for Hadoop that may not even be running the Windows operating system. Perhaps I want Linux and I want to put Cloudera on there for my Hadoop. I could want Hortonworks on top of Windows, but I kind of get to pick and choose here, because I could also have my SQL Server sitting on a data warehousing environment. I don't have to use these hard partitions for Windows. We're all data professionals. We see the amount of data and the different types of infrastructures that we're dealing with grow. Kyle, can you tell me, have you seen or had any experience with folks kind of utilizing the appliance in this way?
Yeah, and I definitely think this is the trend. I think at some point in the near future, people are going to look back on the era of going, hey, remember when we used to have an OLTP machine and a separate machine for OLAP, for decision support? Remember when we used to have to separate them? And that'll appear like another era. What we're seeing now is people wanting to have OLTP, so transaction type workloads, and data warehouse applications having equal access on the backplane of a system to the same data set. It's just so much more effective from a performance standpoint and from a management standpoint. And we've had a number of customers that have deployed actually entirely different workloads, even different operating systems in the same enclosure. We had somebody with an ERP application that was running on SQL Server, and they set that up in one partition, and they picked a different data warehouse product that ran on Linux. And they put both of those environments into the same machine because they wanted common access to data, and they wanted to communicate between the two systems effectively, instead of, again, the network is the evil, instead of having the latency that happens when you're going out to disk and when you're going out to a network. So I think we're not too far from this being the norm, where people will have OLTP and OLAP environments in the same system frame accessing the same data.
Absolutely. And it's such a fantastic way that the hardware is just that flexible. So to add just a little more to this, let's talk about analytics real quick. So the people who are using SQL Server 2016, in the recent release, I believe CTP 3.3 was recently released. We've got some capabilities, the beginning for us to be able to utilize R, to be able to do T-SQL R queries, and to be able to utilize them against a SQL Server repository. So let's back up a little bit and let's just talk about what R is, and even what data scientists are out there doing. Right now, data scientists, they typically use R or Python. Those are the two big things in the market. R is basically a language that they use, and the way this works is it takes a lot of data, a massive amount of it, and it crunches it in memory. Well, the big problem with R is it doesn't page out to disk. It doesn't have a mechanism to be able to do it. So you may have hundreds of gig worth of information that you need to load into memory, and if you don't have enough memory to be able to handle some of these computations at some point in time, it just fails. Which you could have data scientists sitting there waiting for hours and hours simply to have something to fail, and then they have to restructure their R queries. So Revolution Analytics, who was purchased by Microsoft, one of the very revolutionary things that they did was they basically figured out how to allow data in memory to fall out to the physical disk. So they could kind of page results out of memory, page it back in, essentially what we've been living with SQL Server for years and years. So SQL Server bought Revolution Analytics, and the Revolution Analytics suite can still be run as a separate suite from SQL Server. However, you now have built-in R capabilities within SQL Server 2016. So if you are looking at a data science project, one of the great things is you can get a system that might not be able to contain everything in memory thanks to SQL Server, but utilizing Superdome X, that's actually something where you can take those massive sets. Now on top of that, you may want to run your R queries on a SQL Server instance that is not your EDW or not your collection and sets of data warehouses. And it's a wonderful place that hard partitions can actually come into place because you remove that network latency from having to move data back and forth across the network, and you're literally able to move it at blindingly fast speeds across the device in and of itself. Similarly to that, I would talk about polybase and big data. Now, we're not going to dive into this completely today, but essentially what polybase is it's been around, I want to say since 2011, 2012, and it's in the APS and the PDW appliances. And what it does is it allows us to define an external table and then pull that data into SQL Server and use a T-SQL query syntax to be able to go out and get that data. As a matter of fact, in SQL Azure right now, they have the capability to make external tables if that's something you want to play around with. We will have that capability within 2016. The fantastic thing about an appliance like a Superdome X is often you need to go out and stand up a Hadoop environment. Typically, people will go out and get a lot of cheap pizza boxes for that. But eventually that gets to be an issue as well. There's always a maintenance issue that gets as a pizza box environment gets too large. One of the wonderful things you can do is you could take a hard partition and you could set up your Hadoop environment within that hard partition. And you could have SQL Server sitting on another hard partition. And you could use polybase to be able to use external systems. Now the thing to keep in mind is Hadoop, just like any tool that we're talking about, it's not right for every single workload. You want to make sure and hit the right nail with the right hammer. Otherwise, we're just pounding our heads against the table, and that's no good, especially when we've got nails on that table. So what we want to do is make sure and use this for the right thing. This is an area where I want to slam a lot of data into a system very, very quickly. Sensor data, machine data, weather data, social media data. There's a whole host of things I may want to track that may produce hundreds of megabytes per hour, and I may have hundreds of devices I need to pull it into, which equates to gigs, if not terabytes per day. That's a fantastic use case for big data, and then you use polybase through SQL Server to put an external table on top of it and use our optimizer and the statistics within that optimizer to go out and run queries. Not only that, you don't have to go out and find people that know Scoop and Pig and all these different things to be able to pull data out of polybase. You can use the same T-SQL syntax that you already know and the queries that you already know how to write to be able to pull that data into SQL Server and expose the results, be it in reporting or however you need to be able to do that. I see we've got a couple questions real quick. Before I transition over this next slide, let's see. Jeremy would like to know if there's any additional details on a white paper on Superdome X. Kyle, I bet you have something that you can give out on that. We may be able to get you something a little bit more about that, Jeremy, afterwards. And he's definitely looking for something having to do with hard partitions. That's a very interesting topic for him. So Jeremy, I promise you before we get out of here, we'll make sure and give Kyle a little time to probably point to a website or a web page so that way we can get you in the right direction.
Yep, easily done.
Excellent. So Kyle, I think next we're going to talk a little bit about the hardware as it aligns with the device and how this actually reflects and translates to business, so we can pull up a little bit from the technical.
All right, I'll wait for the 5-second delay as we switch slides, and then I'll jump in. So three huge benefits of this approach. One is the faster insights. And you've heard Brad talking about the importance of in-memory computing. I think that's the other shift, is eventually people are going to look back on systems from the early 2000s and say, we can't believe you stored everything on disk. Why would you do that? Well, the answer is we didn't have an alternative. But disk is so slow compared to running things in memory and in the same backplane of a system that the fact that you can run stuff in memory has a huge, huge benefit. And we've got a lot of different variable cores that you can buy, because not every system, again to Brad's point, you want to figure and build a system specific to the workload case. So we've done data analytics where we've looked at a certain workload, and we saw literally 12–14% CPU utilization. And all of the activity in the system was I/O. Well, if that's the case, then the worst thing you can do is buy CPUs that have a huge core count because you're throwing away money on licensing that you could be saving. So in certain environments that are I/O intensive, you want to have CPU cores with or CPU sockets with as few cores as possible to keep your costs down because you don't need a lot of compute power. In other environments, compute power is everything. I/O is minimal or everything's running in memory, so that's when you want the ability to have a system like this that can go up to 288 cores. The second thing is the amount of flexibility. And we've talked about different configurations and different amounts of flexibility, but the electronically isolated partitions, that's just a huge benefit because you can allocate and dedicate resources to different workloads, and you don't have to worry that you're stealing from Peter to pay Paul because they're hardwired to those specific use cases. And the third thing, and this comes up over and over and over again when we talk with customers, and I was just involved with IDC that was writing a white paper about Superdome X, and every customer that was interviewed brought up the high availability as one of the key reasons that they went with this product. It's literally 20 times more reliable than a general purpose x86 server. It's got a number of features that provide high availability and uptime that isn't available in any other system. So again, that speaks to customers that used to run their mission critical workloads on expensive Unix systems. This gives them a very cost-effective alternative. Next.
Excellent. And that's a wonderful transition for me to be able to talk about availabilities and from component to the complete solution. So I'm going to ask you again, Kyle, for a little more insight on this.
Yeah, so I won't read everything on the chart. We could spend a half an hour on it, but I want to give two examples of features that are unique to Superdome X. In the middle of the chart, you see something, the error analysis engine. So what this has got, and it's unique to the Superdome X, there isn't another x86-based product that has this, is on a proactive basis, the system has software that is constantly monitoring all of the major elements of the server. And what it does is it looks for warning signs that things could be problematic. And then it diagnoses them. And then, in many cases, affects self-healing so that the system continues to run without any operator intervention required. So it anticipates problems, diagnoses them, and takes actions to remedy them. So the users have no idea that anything was ever about to go wrong because it's averted before anything can happen. But the second thing I want to highlight is a drill-down version of that, which is something called firmware first. So when memory fails, and if you're going to have a failure on a system, it's typically memory. When memory fails, one of two and frequently both things happen. First is that frequently, when memory fails in the last millisecond before it goes offline, it corrupts data. So the problem with that is as this memory fails, it corrupts data. That data gets sent into the operating system, loaded onto storage, loaded into application uses. So if you're running a healthcare information system or an online booking system or whatever, the fact that you've got corrupted data but you don't know where it is a major problem. The other thing that happens frequently is when memory fails, it can crash a partition. So what we do with Superdome X is at a firmware level, it looks for warning signs that memory is about to go bad. And if it meets certain criteria, it takes the memory offline and routes around it before that memory has a chance to fail and do any damage. So a lot of the benefits that you see from Superdome X are simply elements that anticipate things are going to go wrong and then takes action independent of any operator to make sure that they don't have any negative impact. We can go to the next slide.
Excellent. And I have a very specific question from Larry. I don't know if this is something you can tackle or not, but it's definitely hardware related. It is, can you tell us more about how the mezzanine SSD cards are used other than for read caching when using vSphere or Hyper-V?
Frequently will function as a way station or as an alternative to disk in memory for environments that are not taking place in memory. So, and this is something that you've seen Oracle do with Exadata, is to try and make it a little faster. They will use flash stored devices whenever they can. But that's where you'll tend to see them in use. However, there's a cost premium that you pay for that. So frequently, it's more cost effective to go with a high memory content combined with minimal flash if you need it. But depending on the analysis of the workload and what you're trying to accomplish, flash is certainly a viable option. So it really comes down to the specific use case. And if you work with HPE on any sort of a proposal, we have solution architects that understand database environments and how to optimize performance. So we never just sort of generate a price proposal and say, here's what you ought to buy, here's the bill of materials. It's always based on an analysis of the specific use case and the workload, and then figuring out what's the most cost-effective way to achieve the performance and the availability that you need. So that's a high-level answer, and a deep dive we can do anytime with a specific workload. So we can fly through this. We can show the next slide as well. I just wanted to give some examples that are up on the screen here that show Superdome X. DL980 is an x86-based 8-socket server that we had in the past. And you see there's so many different areas where there's a benefit that Superdome X has uniquely. DL980 had one or two, and generic x86 servers don't have them at all. So we can move on. I won't read all the content on these, but there's quite a few features. It isn't just one or two things that are superior.
Excellent. Oh, sorry, and I was going to say, so I think next up we've got a use case on the SBI liquidity market and why they chose Superdome X for their demanding workloads.
Yeah, we've got a lot of use cases that we've documented. Very few of them are public-facing because customers don't like to take calls and such, but SBI wonderfully was very open about having their name used in a public forum. So these folks have a business that was just growing exponentially. If you look at the number of the trillions of dollars they trade, it's actually bigger significantly than the national budget of Japan. Look at the number of accounts that they've got. And they had a problem that every customer loves to have. Every company wants this problem. We are growing faster than we can keep up with it. We have more customers than we know what to do with. We have more demands on a workload. So they had started off with SQL Server. They wanted to stay with SQL Server. They didn't want to say, well, we can't support this environment past a 4-socket server, you know, the typical smaller systems that you tend to see. So with arm in arm, Microsoft and HPE went in and worked with the customer, and we devised this system where we combined multiple servers into a single Superdome X. And in doing that, we're able to accomplish three things. One, we got a nice performance increase, so 16% isn't bad. The other thing that the customer loved, which is we significantly reduced their software license costs. And the reason for that is that when you scale an environment vertically, when everything is in one server, it's much more efficient than when you scale horizontally among multiple servers. And IDC did a study. It's on the HPE website. IDC did a study, and they said for mission-critical workloads, you typically reduce your overall cost by 35% when you can scale vertically in a single system. Because there's software savings, but also there's significant savings in networking, because it's all one system. You don't need networking. And in management and software licenses that manage the environment as well. But the huge win for SBI, those are two nice features. The huge win was we were able to reduce their system downtime by 60%. And again, this goes to the fact that it's such a highly available system. And one of the big savings there is reducing downtime due to servicing. Because with these electronically isolated partitions, you can service one partition, take it down, move the workload to a different partition and service that other one while the other one is taking its place. So the fact that you can rotate partitions that are live and active allows you to service the system in a round-robin way instead of taking it down for hours at a time. Next slide.
I think that takes us over to questions. So we've been answering questions as we've gone along. Now, Steve, I apologize. I probably had a point in there. I was going to throw it to you, and I did not. Any thoughts that you'd like to give us?
You know, you guys did a really good job of covering what the value of this is. When I look at it, because I come out of the big data warehouse type of scenario, and looking now at tabular models and these big in-memory potential, I love this. This is between in-memory and column data stores and the ability to expand and use that capability on the platform is phenomenal. So as you get into seriously large enterprise analytics solutions, we talked about R, but some people aren't there yet. If you're looking at tabular models and you're going, we love to scale this and not go into multidimensional, now you're looking at a hardware option that actually fits that mold and allows you to take advantage of it. So there's obviously in my world, when I look at those things I'm really excited about, and looking at the capabilities of 2016 in combination with this hardware just allows us to continue to grow and simplify. One of the things that stood out for me was the SBI comment, reduce their downtime. If you can simplify your data warehousing environment and your analytics environment so you're less focused on all the moving parts, and I can use Tabular to combine data so I don't have to actually do a bunch of ETL, that's huge. So I think these are some great opportunities to just take advantage of hardware and the software and the technology that are capable now of taking advantage of the hardware and just seeing how things progress. That's where I'm at with that. So.
Excellent.
Nice job, you guys.
Thank you. I've got a lot of questions that are starting to pour in. So first, a comment from Richard. Richard, you're absolutely right. He would say this is also an excellent environment for VMware and consolidation, or for VMs. You can utilize VMware or Hyper-V on this, but that's absolutely correct. Kyle, please correct me if I'm wrong, but I believe you have 8 separate blades that could be individual hard partitions or could be utilized within a consolidation appliance, correct?
Yeah, that's exactly right. In fact, at VMworld, they brought us up on stage because they've now set a number of world records for VMware deployments using Superdome X. So, and they did a huge initiative, VMware organized, where they got IBM on stage with HPE. We used IBM storage and Superdome X from HP, and it was sort of like, look at the marriage we've brokered, because VMware is so proud of the fact that they've built out these massive scaled virtual machine environments on this platform. And this is a big strategic win for VMware, because as customers are looking at virtualization environments and they're looking at their aging Unix systems, RISC processors, those systems aren't part of the fold. And a lot of companies said, well, we're not ready to move those key applications off of our old Unix machines because we need high availability, and you can't get that with x86. Well, the reason VMware loves this product is they can go to those customers and say, you can absolutely get the high availability that you got with your Unix systems. You do it with Superdome X, and then you get the benefits of virtualization. And in the chat room, I just put a link to the white paper that we've got on all the high availability features of Superdome X.
Oh, excellent. Thank you, Kyle. Jeremy, please make sure and check out that link. Next up, we have somewhat of a comment from Glenn. I appreciate the platform, but I feel like Microsoft is much more interested in promoting SQL and Power BI than Azure than on-prem. And I'm going to take that one. So, Glenn, I'm going to do my best not to violate any of my NDAs, but I can tell you as an MVP, one of the things that we get is we get really unprecedented access to the SQL team and the people who run the program to be able to talk to them back and forth and pick their minds. And I can tell you that, yes, there has been a big push for cloud over the years at Microsoft, but over the last 2 to 3 years, one of the things that they readily recognize is that this is never going to be a 100% cloud world. This is, at best, a hybrid world. So one of the things that is a really amazing thing to come out of Azure is that the developers for SQL Server actually spend time being frontline support for Azure, and then they go back to be developers on the program. That has led to some really incredible advances that we are getting in SQL Server 2016, simply because it makes their lives easier when they have to help run support. And we see some of those things already rolled out into the cloud, and we will get them in 2016. For example, the query store, the non-cluster column store, the in-memory OLTP column store indexes. lot of really fantastic things that are coming. So trust me, I understand it may feel that way because we've heard cloud, cloud, cloud so much, but Microsoft readily recognizes that there's always going to be an on-prem portion of the world, and they really want to make sure SQL Server is the best platform for it. So, I would say take heart in that. Let's see, next we have Mark Duffy. Mark said, what is the nomenclature of Superdome? If a customer says they're looking at a BL XXX or a DL XXX, how do I know if this is a Superdome?
If they say BL or DL, then typically they're talking about the ISS Proliant servers. So Superdome X is invariably called Superdome X versus like DL 580 or DL 380. So that's what differentiates it. It's not a bunch of numbers and letters. It's a word, Superdome X.
Excellent, excellent. Well, that makes that very clear.
And I just put into the chat room a URL for a white paper that specifically talks to how to configure and run SQL Server 2014 on Superdome X. Oh,
fantastic. I love white papers like that because when the hardware vendor takes time, I'll tell you frankly what they do is they bring in probably an independent vendor like us as well to be able to work with that really knows SQL Server, and we set it up and we run it and we run load test against it, and they do a lot of due diligence before they publish that white paper to make sure that here's the best way to configure it. Personally, when I go on a performance tuning engagement, one of the things I look for is I look for the types of servers we're using, and I look for those white papers to make sure that we've set things up to the best practices and configuration. So thank you, Kyle. That's really awesome to have out there. Let's see. Jeremy has another question. Do you license SQL Server for each individual hard partition or traditional per core count on the Superdome X?
Okay, that's simple. You look at the total core count in the system that's deploying SQL Server. But let me give you an example of real case. So the customer that I talked about before, they had, say, a 200 core system. They were running SQL Server on 80 cores, and this other environment had 120 cores. So they're running, so total of 200 cores, but when they licensed it, it wasn't how many different partitions they were running, it was the total cores being used. So they went to Microsoft and they said, we understand this is a 200 core system, but it's got hard partitions, not soft partitions, and therefore we only have to pay for those cores that we're using in the hard partition. So they only had to pay for 80 cores. Now what's different is if you were running SQL Server on, say, 120 core regular Xeon processor box with soft partitions, even if you were only using SQL Server on half of the cores in that box, you still have to license the capacity of that system. So that's one of the cost savings associated with hard partitions is you look at the cores that are actually being deployed to run SQL Server, and you only have to pay for those. You don't have to pay for the total core count in the overall machine.
And Kyle, can you paste that URL again? I'm looking in the chat window, and for some reason I think it came to organizers and panelists only. You want to select the drop-down box for the entire audience.
Hey, Brad, if you go up to the top of where Jeremy initially asked his questions, I put it in there to all.
Oh, excellent. Thanks, Liz.
No problem.
That's great. And did you get both of them?
I got the one.
I've got a white paper on RAS that was at 1:45 my time, and then another one at 1:48.
Got it.
Perfect.
Thanks very much, Liz. Oh, thanks. That is coming through right now. All right, let's see. Jay said could not locate the SQL info on the white paper. Yep, we will. So Liz is adding that right now, and that will be coming through. Let's see. Scott asks, can you comment on key security features of Superdome X? And so, Scott, I think this is one of the things that we talked about with the hard partitions, specifically that that if you set up a hard partition, this is essentially like having a box that's in a completely separate domain. You could set up different domains. You could have that within a forest, or you could have no trust whatsoever. You could have a completely different operating system. You could run Linux on one hard partition, or Unix, and you could run whatever you need to run on those individual OSs. And then you could have another that's Windows. Kyle, anything you want to add to that?
No, that's exactly right. It's almost as if you had two servers sitting next to each other on a floor. If you break into one server, you're not going to be able to break into the next one. You're going to have to try and get into it all over again, because the only thing that partitions share is the backplane of the system. So and the backplane of the system isn't going to provide easy access to one partition if you're in another one. So you really are truly able to have these function as separate instances. They just share a common backplane.
Excellent. And there are additional technologies. I'll be honest, I did not dive into the oh, I'm sorry, Scott says, okay, I understand the isolations. What else about the hardware encryptions?
So I don't have any incremental data on that, but that's something we can certainly look into.
Okay, excellent. And Scott, we'll get your information that you've signed up with from the webinar, and we'll make sure that we get that over to Kyle so he can reach out to you with some information about the hardware security. No problem. Let's see. I think that's everything we've got. We've got about 6 minutes left, so if anybody else has a question, something that we did not hit, what I was starting to say is I didn't go into the 2016 security features simply because there's a lot of great 2016 webinars we've done. I believe I've done one as well. And if nothing else, if you can't find it on our site, go to Microsoft Virtual Academy and type in Always Encrypted, and you'll be able to find some of the newest information about 2016 and the way that they're actually encrypting data from disk into memory and only encrypting it using the ADO.NET connection strings. And you can use multiple different applications to be able to use Always Encrypted. I believe there is a driver as well that allows for Always Encrypted in Java, and I'm not sure if there's one for PHP, but I know they're looking to broaden that base and make sure that there's a wide application set that supports that. Let's see, one more. Satish said, how can you differentiate from flash storage servers? So one of the key things I would think off the top of my head is if you're looking at flash storage, typically you're still going to have to hook up a box to that to be able to utilize that flash storage. Kyle, is there anything that you want to add to that?
No, that is what it comes down to is you're going to be 10x faster because you're using in memory versus you're at least 10x faster because you're not using system backplane memory or access. You're using within the same blade itself. So that's what it comes down to. So in memory is faster than flash. Flash is faster than spinning disk. So that's what the hierarchy looks like.
Yeah, and to add to that a bit, the InfiniBand connection that Kyle was talking about on the Oracle Exadata systems, that's no slouch. That's a 56 gigabit network. So whenever you transmit across the line and you connect to a back-end flash storage vendor, be it whatever vendor that you want to use, you've got a connection and a bus line that you're going to have to, whether you're using fiber channel NIC cards, whether you're using 10G gigabit Ethernet to be able to connect to that, or you're using InfiniBand, which is going to be the 56 gigabit. You're going to hit potentially a throttle point. And if you've ever moved a disk from one folder to another on an SSD drive sitting on the same computer, you'll notice the wicked fast copy time. That's not throttled because it doesn't have to go out to the network and copy over. So just one of those things, we're cutting out the network copy mechanism. Yes, and Glenn said, plus there's no issue with having SDX connected to an AFA. So agreed. I think we've got about 3 minutes to go. I think we've answered just about every question we got. I don't see any new ones coming in. But Kyle and Steve, I wanted to thank you guys both very much. Liz, thank you for having us.
Thank you guys, I appreciate it. And if you guys want to share this session with anybody or you want to go back and watch it, it will be on the website by end of day tomorrow, and you'll also receive an email tomorrow with the link. So thanks again. Thanks, Steve. Thanks, Kyle. And thanks, Brad. And we'll see everybody again soon.